Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. We are still working on the Algebra 1 uh, course curriculum. And today we are going to have a quick review of fractions. Sometimes I get questions from students about fractions. They are tricky, whatever. In fact, I have in the Math Made Easy playlist a whole session on fractions, but today we are just going to look at the different operations like addition, subtraction, multiplication, and division of fractions. We start with the multiplication and division since they are easier. In fact, I'll do all the multiplication and divisions first, and then we'll go to the addition and subtraction, which ridiculously are a little not, I wouldn't say tougher. I mean, I don't see anything tough in that, but not as easy as one, two, three. No, not as easy as multiplication. Alrighty, so the first question says 1/5 times 10 over 16. Well, what you have to do is to simplify as much as you can and then just multiply the numerators and the denominators. So I see that 10 is divisible by 5. Some people would say, well, I can simplify 10 and 16 by dividing by 2. Of course, that's what we are going to do eventually. But I can see that 10 is 5 times 2. So if I divide top and bottom by 5, I get the 2. And then 2 and 16 are both even, meaning they are both divisible by 2. So I divide by 2, I get 1. I divide by 2, I get 8. Notice when you divide 5 by 5, you get 1. Really, we don't write it, but there is a 1 there. So when I multiply the numerators, I get 1 times 1 is 1. When I multiply the denominator, it's 1 times 8 is 8. 1/8 is the answer. The next one is division. Excuse me. You learned that an easy way to do division of fraction is that you look at the second part that we divide by the divisor, and then you switch it to multiplication, and at this, no, you cannot do that, right? You can only if you flip the second proportion. So that becomes 2 over 18 times 9 over 4. Right? So again, some people multiply first and then simplify. It really doesn't make sense. It's better to divide first, right? You can do whatever. 2 and 18 are both even, or 2 and 4 are both even, or 9 and 18. 18 is divisible by 9. It doesn't matter. Whatever you do is, as long as you do it correctly, it doesn't matter which one you do first. So let's say they are on top of each other. So I divide by 2. This would be 1. This would be 9. 9 over 9 is 1. So I divide by 9. So the numerator is 1 times 1, 1 again. The denominator is 1 times 4, 4. So it's 1/4. The next three are additions and subtractions. So I'm going to skip to number 6. And number 6, I see division again. So 1/3, I switch the division into multiplication and I flip over the second fraction. I cannot simplify anything because 7 is a prime number. 7 is not divisible by anything other than itself. And 1, of course, like all numbers. So I just multiply. 7 times 1 is 7. 3 times 2 is 6. If you can leave it like that. But do you know that your teacher may tell you, no, I don't want to see an improper fraction where the numerator is larger than the denominator. So in that case, you say, okay, 6, how many times 6 goes into 7? Only once. So that would be 6 over 6. And that leaves me with 1 over 6 as a remainder, right? Like when you divide 7 by 6, you get 1. And a remainder of 1, meaning 1 over 6. Next one is also division. So I'm going to say 5 over 9, and then make a multiplication, 14 and 6. 14 and 6 are both even, so I can simplify them by dividing by 2. So that becomes 7, and that becomes 3. And again, when I multiply 7 times 5, I get 35. When I multiply 9 times 3, I get 27. Again, improper fraction. So you say, okay, I divide 35 by 27. That's a 1. And the difference of 8. When you subtract 27 from 35, you get 8. So that's 8 over 27. Okay. What else do we need? Next one is so easy. It's a multiplication. You don't need to simplify anything because the numerator is 1. 1 times 1 is 1. The denominator is 3 times 5, which is 15. Number 10 is a multiplication again. I can simplify the 5 and the 20, right? Divide by 5, divide by 5, and multiply. So you get 1 times 13 is 13. 6 times 4 is 24. And these 6 were multiplications and divisions. So we are done with those. Next time you go to addition and subtraction. When you add and subtract, it's a must. You have to have the same denominator. So I have a 6 and a 2. So what do? We find the least common multiple. And how do you find the least common multiple? It's very easy. I mean, worst case scenario, you multiply the numbers and make it everything out of 12, and then later you simplify. However, if you want to do it without simplification, it's easy to look at the factors. The factors of 6 are 3 and 2. The factor of 2 is just 2. Now you see the 2 happens to occur in both instances. And the maximum time it happened in each instance is once, right? Just once. So you write 2. How about the 3? It happened to appear here once, and it didn't appear at all there. So the maximum number of appearances is once. So 2 times 3, because each one of them in each instance appeared once. So 2 times 3 is 6. I take a factor of 6. 6 divided by 6 is 1. 1 times 3 is 3. 6 divided by 2 is 3. I'm sorry, 6 divided by 2 is 3 times 1 is 3 again. So you get 3 plus 3 over 6, 6 over 6, which is 1. You should have noticed that before taking the common denominator, I could have simplified. So that's another lesson you learn, is that when you have, like we did with the multiplications, you see if you can simplify, reduce the work. So you say 3 over 6. I could have said, oh, let's divide numerator and denominator by 3, and I get 1/2. And 1/2 plus 1/2 is 2/2 or 1. It doesn't matter which way you do it, but you have to learn how to find a common denominator. Same thing here. Notice that 15 and 18 are both divisible by 3. I could have divided them by 3, and the problem would be very easy. But sometimes you cannot do that. We are going to assume we didn't see that like we assumed here. So I'm going to say, okay, 6 is 2 times 3. 18 is an even, so 2. That would leave 9, because 18 is 2 times 9. The 9 is 3 times 3. The 2 appeared once. The 3 maximum appeared twice. I don't care about the least number of appearances. No, the most number is twice. So 3 times 3 is 9, and 2 times 9 is 18. So the common denominator is 18. 18 divided by 6 is 3 times 1 is 3. 18 divided by 18 is 1 times 15 is 15. And 3 times 15 is 18 over 18. Oops, again, it's 1. Because that was 5 over 6. 5 over 6 plus 1 over 6 is 6 over 6, which is 1. Here it's not the same thing, but I could simplify the 4 and the 10 before I start. So you see, in these three instances, you could have either simplify first, then find the least common multiple, or find the least common multiple and then simplify at the end. It's the same thing. So this time as a change, let's say I'm going to simplify that. So I get dividing by 2, dividing by 2. It's 2/5 minus 1/9. I see that the 5, this one doesn't have any 5s in it. So the left has a 5, the right has a 3 and a 3. The 5 appear once, the 3 appears twice. So I multiply them together, I get 45. I cannot simplify with, there is nothing common. So here the 2 appeared once in each. Here the 2 appears once in each. But here nothing appears. It appears only on the left. So I write it. I get 2 3s on the right. I multiply by them. 45 divided by, because I use all the numbers, I don't have to say 45 divided by 5 because I will get 9. And 45 divided by 9, I will get the 5. Why? Because they had nothing in common. So it's just, you can say 9 times 2 is 18, minus 5 times 1 is 5. Instead of saying, oh, let me divide 45 by 5, I get 9, and 9 times 2 is 18. And then I divide 45 by 9, I get 5, and 5 times 1 is 5. If they don't have anything in common, an easier way is just multiply, like we did the butterfly. So you say 9 times 2 minus 5 times 1. 18 minus 5 is 13. Over 45 is the answer. Now we still have 3 more. The left-hand side has 10, which is 2 times 5. The right-hand side has 3. So again, nothing in common. So I multiply 10 times 3. And then like we said before, 3 times 7 is 21. Minus 10 times 1 is 10. I get 11 over 30. It saves some time. Instead of saying 30 divided by 10 is 3 and 3 times 7 is 21. Yeah, 3 times 7. Or 30 divided by 3 is 10 and 10 times 1 is 10. Yeah, 10 times 1. I don't need to divide the 30. Only when the left-hand side factors have nothing to do with the right-hand side factors. They are completely different. 5, 3 and 3. 2 and 5, 3. Nothing in common. So you can use this shortcut. Here I have 20 and 15. Oops, no, they are not different. They have stuff in common because the 20, it's even. So 2 times 10. 10 is even. So 2 times 5. 5 cannot be simplified. The right-hand side is 15. 3 times 5. The 2 appears twice. The 3 appears once. And the 5 appears once. I'm not saying again, how many times did the 5 appear? No. How many times in each fraction does it appear? Only once. Once here and once there. So I multiply 2 times 2 times 5, which was 20, times 3. So it's 60. 60, and because they have something in common, I cannot say this times that plus the, no. I have to say 60 divided by 20 is 3 times 1 is 3. 60 divided by 15 is 4, and 4 times 13 is 52. I add them up, I get 55 over 60. And I know that both of these numbers are divisible by 5 because one of them ends in 5, the other ends in 0. So simplifying by 5, I get 11. Simplifying by 5, I get 12. That's the answer. Let's write it neatly. So 11 over 20. Wait a second. Something is wrong. I did something wrong. I said this is 20. No, definitely I did something wrong. What did I do wrong? This is 452, yeah. Oh no, it's not wrong. For some reason, I thought I messed up something. No, I did not. For once, I did not. Okay, let's do the last one then. 5 and 9. Well, nothing in common. So when there is nothing in common, you don't have to say this is 5 and this is 3 times 3 because you know there is nothing. Five is a prime number. So unless this is a multiple of 5, they wouldn't have anything in common. So the common denominator is 4 times 5 or 45. 5 times 9 or 45. Why 4? 45. You see, I have to do something wrong. And because they are independent, they don't have anything in common, you multiply 9 times 3 minus, and you multiply 2 times 5. So you get 17 over 45, and that's it. This is the conclusion. So that was an easy lecture. Just a quick review of fractions. Um, it showed you that sometimes you can use a common denominator that is smaller than the product. So here I had to multiply 5 by 9, but here I didn't have to multiply 20 by 15. I just multiplied 20 by 3 or 15 by 4. What I'm telling you is that if the worst comes to the worst, don't do that. But if you can't see if you can't find the factors, I could have, for example, if I take this problem, I can take a common denominator of 20 times 15, which is 300. I know 2 times 15 is 30, and there is a 0, right? And then I say 300 divided by 20 is 15, because now I can, since I assume they don't have anything in common, I can multiply 15 by 1 plus 20 times 13, which is 260. And that would have given me 275 divided by 300. You can divide by 25, but if you don't know how to divide by 25, even though we talked about it, divide by 5. Dividing this by 5 would give me 55. Dividing that by 5 would give me 60, which is the 55 over 60 that you see here. And that would have given me 11 over 12, but it's a much more work. It's larger numbers you multiply. So it's better to learn how to find the factors of each fraction and take what's common between them, if there is any, and just use a simplified or a smaller common denominator. As I said, it's not wrong always to multiply these two guys in addition and subtraction and use it as a common denominator. It wouldn't be the least common multiple, but it's still working. It will work, but it's more work. It's better to learn how to do it in a simplified way. Okay, I hope that clarifies the thing. The only thing you gain by using by multiplying them is that you can apply the easy method of multiplying the diagonals and adding or subtracting them. That's the only thing you learn, but other than that, the simplification is more in depth. Okay, thank you very much for your time. Next time, maybe we'll take a review of some of the stuff we did so far, and then we move, say, to inequalities or absolute value. I haven't yet decided which one I start with. Thank you for your watching, and have a great day. Bye.